Hi, this is Jan with IQRF, and in this video we will show you how to work with an IQRF interoperable product, NetIO Power Cable Smart Power Socket. We will connect the socket to the IQRF gateway and show the basic operations we can do with it. First, let's introduce an interoperable device and gateway. Then, let's show how to connect and disconnect devices, and then test communication with the power plug. IQRF interoperable products are marked with the IQRF interoperable label. They are certified for interoperability, which means that products can communicate in a uniform way, and incoming messages come in a uniform IQRF format. More on iqrfalliance.org/IQRF-interoperability. Each device is provided with appropriate documentation from the manufacturer, where you will find a description of the device and its specs. The IQRF gateway, labeled IQRF Interoperable, has an IQRF Gateway daemon and an IQRF web app pre-installed. It provides communication with an IQRF repository. You can communicate with the IQRF gateway using the JSON API. If the device is equipped with a bonding button, it can be added to the network using local bonding. Some devices only allow IQRF Smart Connect or Auto Network to connect to the network. For more information on these methods, see IQRF tutorial number 4, Create the IQRF Network. For local bonding, you must be able to initiate a request for a bonding on the device, for example by pressing a button. The IQRF Power Cable socket has a button that is used for this purpose. In addition, it has a label containing the IQRF Smart Connect code and a QR code containing this information, which will be used in a case of Smart Connect bonding. There are various IQRF network managing tools. These are mainly IQRF Network Manager, IQRF Web App, and IQRF IDE. All of these tools allow you to perform local bonding. Mobile app provides you the best user experience with the IQRF Smart Connect, although even other two managing tools can perform that. For now, the Auto Network can be executed only in the IQRF IDE application. Disconnecting, or as we say, unbonding the device from the IQRF network can be done in the coordinator, where the coordinator sends a request to disconnect the device and, if available, disconnects it from the network and deletes its bonding information. Likewise, the relevant bonding information will also be deleted from the coordinator. If the device is not available in the network, the bonding information can only be removed from the coordinator. The device can be removed manually, independently of the coordinator. In an IQRF network, an IQRF coordinator is typically located in an IQRF gateway to which IQRF node devices are connected. These can be up to 239. The IQRF gateway is usually connected to the local router, which connects the local network to the Internet. Internet data storage and analysis services, predictions, visualizations, and statistics can be provided here. However, there are also IQRF gateways that have WAN connectivity, in which case the IQRF network is directly connected to the WAN by this gateway. Let us show a variant with connection of the IQRF gateway to local network. The IQRF Gateway daemon and the IQRF Web App software are installed on the IQRF gateway. Local network management software, such as Node-RED or other applications, may be installed. Within the local network, these services can be accessed from local devices via the local IP address of the IQRF gateway received from the local router. From local computers with the IQRF IDE application installed, The IQRF gateway can be accessed using the UDP protocol and use all the tools of this application. You can access the IQRF gateway via WebSocket from the mobile device on which the IQRF Network Manager application is installed. If the mobile device is in the same network as the IQRF gateway, a local connection can be used. If your mobile device is on a different network, you can use a secure tunnel, such as Pixla.online. IQRF gateway and mobile applications are linked to the IQRF repository, where update packages, drivers, and device descriptions are available. Secure tunnels can be used for remote access from computers to locally running gateway applications. To connect or to bond any IQRF interoperable device to the network, you will need a network coordinator to which the device as a node will connect. The coordinator can be placed in the CK-USB development tool or in the IQRF USB interface, but this is not the IQRF gateway and there are no IQRF gateway daemon services available. In our example, we will connect the IQRF power cable socket to an interoperable gateway. You can either create one yourself by installing the required software on an upboard or a Raspberry Pi device, or by purchasing a ready gateway, such as the Aurora Hub IoT gateway. In these gateways, you will find the IQRF gateway daemon and the IQRF web app installed. You can install local Node-RED in Gateway and run there, for example, a dashboard. In the example, we will use our own installed gateway, but you will proceed very similarly in case of, for example, Aurora Hub IoT gateway. First, connect the IQRF gateway to your LAN network and read out its IP address. Depending on the gateway type, you can use most Wi-Fi or Ethernet cable connections. In this example, we will connect the gateway using an Ethernet cable. To connect the gateway to the network in any other way, use the information provided by the manufacturer of the gateway. If you cannot easily find the IP address in your LAN network, for example from the information on the router or via the Thing application, you can use Pixla Online Remote Management. You can learn more about adding your gateway to Pixla Online in the webinar called IoT Gateways and Pixla Remote Management Software. After successfully accessing the web interface of your gateway, you log into IQRF web app to find out what local IP address your gateway received. You'll use it in some next steps. Using the IQRF Network Manager mobile application, you can add the device to the network using local bonding or IQRF Smart Connect. You can also remove the device from the network. You can check the network topology or save the communication log. IQRF Network Manager is available on Google Play. Let's show bonding using the IQRF Smart Connect first. The IQRF Network Manager mobile app is able to read a QR or NFC code containing device identification parameters, the so-called IQRF Smart Connect code. In the case of IQRF Smart Connect, it is not necessary to have the same access password on the node as on the coordinator. Gateway must be in operating mode because the mobile app will connect to the gateway using the JSON API. In the mobile application, enter the IP address of this gateway and connect to a port 1338 via the WebSocket. If the mobile device with the application is not in the same network as the gateway, it is possible to use the Pixla Online tool to create a tunnel to the port 1338. In the mobile application, select Smart Connect with QR code and retrieve information from the QR code on the power plug. In our example, this is an interoperable device, so all necessary device information is retrieved from the IQRF repository. The device is added to the network and all available parameters are read from it. The socket can be remotely controlled using switches in the mobile application that internally correspond to JSON commands sent to the JSON API of the IQRF gateway. The device can be removed from the network via the mobile application, either entirely on the coordinator side and on the socket side, or only on the coordinator side, which would probably be used if the socket is not available in the network and needs to be removed from the gateway. If the situation is that the unbonding occurred only on the coordinator, or the network coordinator is no longer available, and we need to delete the bonding information directly from the device, we can do it manually on that device. Press and hold the bonding button on the socket and plug the socket into the power supply. As soon as the green LED goes out, we immediately release the bonding button. This will unbond the socket, which is indicated by the flashing LED. To add a device by local bonding, press Bond Device and then press and hold the button on the socket until the green LED lights up. The access password must be the same on both the coordinator and the socket. To find out the network topology, click Network Discovery. You can find the communication log by clicking on the icon in the upper right corner. You can access the IQRF web app on the gateway via the internet browser to control the connected IQRF network. Web app offers further gateway settings such as setting up regular network communication scheduler or connections with clouds and so on. Enter the gateway's local network IP address into the browser or use the tunnel created by the Pixla Online, as you can see in the example. In the Network Manager, you can add devices to the network using local bonding or IQRF Smart Connect. During local bonding, you have to press and hold the button on the socket again, and it is necessary to set the same access password on the socket as on the coordinator. If you will bond the device using IQRF Smart Connect, you will enter the IQRF Smart Connect code found on the socket. To determine the network topology, click Discovery. You can remove a device from both the coordinator and the node at the same time when the device is physically available in the network. If the device is not physically present in the network, you can only unbond it from the web application on the coordinator side. The device will not receive any message about unbonding, and to delete its bonding information, you have to use other methods, such as manual unbonding. In the IQRF IDE application, we will show how to connect to the IQRF gateway using the UDP protocol, how to add devices to the network using local bonding, IQRF Smart Connect bonding, and Auto Network. We will show you how to unbond the device. We will also show some advanced techniques using CADs. In Pixla Online, you have acquired the IP address and now use it to connect to gateway from a computer in the same LAN using UDP protocol and the IQRF IDE application. In the Tools tab, select the IQRF Device Manager item, click on Add UDP Device, and enter the detected local IP address of the IQRF gateway. Select the type User Gateway. To connect the gateway via UDP, you must switch the gateway to a service mode. Thanks to this connection, you can use all the tools provided by the IQRF IDE application. Watch more detailed videos about working with the IQRF IDE application and the IQRF network on the IQRF YouTube channel in the Tutorials 2019 playlist. In case of local bonding, the device and the coordinator must have the same access password. When you purchase a device through iqrf.shop, you get devices that have an access password set to zeros, which you should subsequently set to a different secure password. When connected to the power supply, the unbonded socket will flash repeatedly. In the IQRF IDE, in the IQ Mesh Network Manager, on the Control tab and under IQ Mesh item, select Local, and when Auto Address is checked, start the action with the Bond Node button. During the next 10 seconds, press and hold the bonding button on the socket until the green LED lights up. This gives the device a network address. Then we will determine the network topology using the discovery. If you want to disconnect the device from the network, uncheck the Only in Coordinator checkbox in the IQRF IDE. Set the network address of the device to be unbonded and click on the Unbond Node button. Alternatively, use the Clear All Bonds button to delete all devices from the network. If we check the checkbox Only in Coordinator before unbonding, we would delete the bonding information only from the coordinator, and then we would have to unbond the device another way. For successful bonding with AutoNetwork, it is necessary to set the same access password on the device as on the coordinator. In our case, all zeros. Then, just start the IQRF IDE with the selected AutoNetwork parameters, and all devices within the network range with correctly set access password will be automatically bonded. It is now possible to control what address each device gets and if it is necessary to create physically overlapping networks. This is already enabled in the IQRF IDE. Learn more in a webinar called IQRF News, October 2019. If you want to add the socket to the network using the IQRF Smart Connect, type its IQRF Smart Connect code into the box and click on Bond Node. The socket gets network address assigned. Then we determine the network topology using the discovery. In Map View, we see what virtual routing number the device has received. If the device could not be removed manually using a button and the procedure described, its bonding information can be deleted using CATS service tools. To any IQRF transceiver you are not using, upload the software by clicking on the Create CATS button in the CATS service tools window on the Control tab. On the DPA Service Mode tab, enter the appropriate password. The device is configured in the access password. In our case, it is all zeros. It means you don't enter anything. Click Connect and then plug the socket or other device into the electricity. The service tool connects to the device thanks to access password knowledge. Therefore, it is important to have a strong access password throughout the network when operating a functioning network. Using CATS service tools, we can remotely program device, unbond it, connect, backup, restore or reconfigure and so on. In our demo, we unbond the device. The bonding information was only deleted on the socket side. Then we disconnect the device from CATS service tools and we can start to use it normally. For example, connect it to another network. If the IQRF device uses a DPA plugin version 4.10 or higher, it is possible to reset the device to factory settings. This means unbond it and delete the access password manually without using CATS. Just hold the button on the socket long enough after connecting the socket to the power supply. Wait for green LED on the socket to flash twice and then release the button immediately. This resets the device into the factory settings. You can communicate with the power plug as well as with other IQRF devices using DPA commands. Refer to the socket documentation for instructions on how to turn the socket on or off, how to read all sensor values from it, or how to set the socket to its default state after power is restored. Let's first look at the commands to turn the socket on and off. The first 4 parameters are the same, only the value in P data differs. We will try to switch the socket on first. Set network address, set peripheral number to binary output, set peripheral command to set output, select hardware profile ID for NetIO socket, and insert data to switch socket on. As you can see, the socket has turned on. You only need to change the last number to 0 to turn the socket off. Now the socket has turned off. Now let's take a look at reading the sensor values from the socket. Set the network address of the socket. In peripheral number select standard sensor. Set peripheral command to read sensors with types. Set hardware profile ID to NetIO socket. And enter data into pdata, which specify all the sensors present in the socket. Send the command. In the answer, you will find values from all sensors with their description. We can set the default state of the socket after power recovery to off, on, and last. To set the default state to off, enter the following two commands. Similarly, we would set the default state to on. To set the default state to last, enter the following command. As mentioned before, IQRF Gateway can be communicated using the JSON API. Refer to the JSON command examples in documentation to learn commands for acquiring the number of devices in the network, a list of discarded devices, or read sensory data from a standard IQRF sensor. IQRF Gateway documentation can be found here. For example, in the mobile application log, you can see all communication with the IQRF Gateway, and you can try these commands sequentially through the IQRF web app or through your favorite platform. If you create a locally functioning Node-RED application on the IQRF Gateway, you can send commands to the IQRF network and display the measured values or control the device. On the IQRF Gateway, you can set up sending IQRF messages via the MQTT broker to the clouds. Instructions can be found at iqrf.org/iot-starter-kit, Part 3 Connect to Cloud. In this tutorial, we introduced you how to connect to your IQRF Gateway, how to connect your device to the IQRF network, how to disconnect it from the network, how to communicate with it, and how to connect the IQRF Gateway to your software platform. Learn more on YouTube in IQRF tutorials. Use IQRF interoperable products simply.